Quiz 5, Question 6. Consider the bonds below with annual coupon payments starting from year 1 till maturity. Make a table of bond prices for varying market interest rates from 0% all the way to 20% for each of the two bonds. Graph the bond prices against the market interest rate using the graph. Explain whether long-term bond or short-term bond is more sensitive to changes in market interest rates. So we've already discussed this in question 5 if you saw that review, but we're going to graph out a value of the bond given a market rate here. So we can call this right here market rate. So to solve, we're just going to find the present value, and then we're going to use this discount rate. Our number of periods is given here, so we'll hit F4 to lock that cell reference in. The coupon payment is calculated as the coupon rate times the face value of the bond. Next, we need a future value. That's the amount that we will receive upon maturity, which is a return of the face value or the notional amount of the bond. Now, if we leave these as positive values, we'll receive a negative value as a solution. So we're just going to place a negative sign in front of the payment as well as a negative sign in front of the future value. That way our answer will be a positive. The payment occurs at the end of the period, and we're showing that right here in the first line where the payment starts from the end of year 1 till maturity. Lastly, what we could also do here is where we have all of these, we've hard-coded in, we can allow the columns to float, thus maintaining the rows so we can drag our formulas down into the right. Oh, forgot to reference B. Okay, there we go. Now we can drag these formulas down, and we can see the relative value. So what we know is when the rate goes to low, bond B is worth more, and when the rate goes to high, bond B is worth less, because the impact of a higher rate relative to the coupon rate is magnified over the life of the loan. That is how long the maturity is. We can see the crossover rate also right here at around 5%. And we can see, yep, both bonds are equal at 5%, which is the par value of the bond.